Hi everyone, welcome to Vedantu J English. I'm Diksha, your chemistry master teacher. So everybody, let me know in the chat box if I'm clearly visible and audible to all of you or not. And today we are going to see, in the last lecture we did mole concept, we did some questions on stoichiometry. Now we are going to do some more questions on stoichiometry that you will really like, because these questions are what they ask you in your exams, right? Then we are going to move towards the limiting reagent. Okay, yes everybody, ready for the class? All the students here, are you all ready for the class? Yes. Can I see your energies in the chat box? And have you done your dinner? Have you all done your dinner? That's why I extended the class. Okay, and have you liked the session? I can see very few likes on this session. Why? So everyone right now like this session firstly, right? Okay. Yes, everybody, firstly like the session so that I can also see your energies in the chat box and in the likes also, right? Still only 7 likes. Why so? No likes, nothing. Why? Okay, chalo. Now let us start the session. Right? And one complaint I have for you, very few students do their homework. Right? Only Ramu has done their homework. Right? Rest of the students, Ramu Raja has done the homework. What about rest of the students? They have not done the homework. Right? Why? We're not doing the homework. Huh? Now today also I'll give you homework and I want you guys to do the homework. Right? Okay? You have to promise me that. Okay, ji? Chalo. Now, let's see that what was the homework that I gave you. Firstly, this was the concept. This was based on number of moles and mole concept, where you have to find the sample number of atoms which have the largest atoms. So, right, what you have to use here, mass is equals to molar mass equals to number of atoms divided by number of molecules, right? Then this will be Avogadro's number. And after solving, you have Avogadro's number. Molar mass you can calculate for all. Mass is given to you for all. The answer will be D, will be the correct answer after solving. Right? Okay. Next is, if SI unit of Avogadro's number. See, Avogadro's number is a simple number. There is no unit as such here. Right? Okay. So, Kelvin per mole, no. Both A and B depending on the context, no. It is particles, and particles do not have any units, right? Chocolates do not have any units. So this will be unitless quantity, right? Okay. Now let's talk about stoichiometry and stoichiometry. What is a stoichiometric coefficient? Right, based on this, though, you will see in like throughout your physical chemistry, I'll teach you stoichiometry coefficient, all of these things. Right now, let us see that what is important here. Right, see students, if I talk about, let's say you have a question that is H2 plus I2 give rise to 2HI. Right, now when you balance this reaction, here you are getting 1, this is 1 and this is 2, right? For you, ma'am, this is just a digit that is before the compound in the balance reaction. But what exactly it is telling you, right? These coefficients, what they are telling you. In terms of mole, we can say 1 mole is equals to 2 mole. That means 1 mole of H2 react with 1 mole of I2 to give 2 mole of HI, that is in terms of mole. Then in terms of mass, we can say 2 gram of mass reacts with what is iodine, everybody? What is the molar mass of iodine, everybody? Beta, I'll tell you about, don't worry. Today lecture is that, na? So why will I not tell you about it? Everybody, chalo. This we can say 126 multiplied by 2. That will be the answer here, right? Okay. So, wait. Wait a minute. Hmm. 126 only you can write here, right? Okay. 126.6, you can take it as 127. Okay, 127 gram to give how much? 2 of HI, right? So the total amount of this is produced, right? And you can also write it in the form of volume, that 22.4 liter reacts with 22.4 liter to give double the amount of this, that is 44.8 liter. Okay, this also you can write it in the terms of volume. You can also write it in the terms of atoms, that 6.022, or I can just write Avogadro's number of H2 molecules, Avogadro's number of I2 molecules give rise to 2 into Avogadro's number of molecules, right? So we can write this mole in terms of mass, in terms of particles, in terms of volume, right? That means just by looking at the reaction, you can tell so many things about that reaction. You can tell about mole, you can tell about particles, you can tell about mass, you can tell about volume, all the things you can tell by just looking at what is the reaction, that is balanced chemical reaction. Okay, I'll give you one more example. You have this thing. Okay? What all the things it is explaining you? It is explaining that this reaction is explaining that 1 mole of N2 reacts with 3 mole of H2 to give 2 mole of NH3, right? In terms of mole, it is giving you the moles here, right? Whenever I talk about the mass here, this will be the molar mass of N2 multiplied by H2, molar mass is 2. It reacts with 6 gram of H2. It gives you nitrogen 14 plus 3, 14, 15, 16, 17, 17 to 38. Right? Okay. Yes, everyone. है ना? Okay, na? Wait a minute. 72, 17, na? It is 14, 15, 16, 17. 34. I'm so sorry. In my mind, something else was going on. Okay, 34. Now, tell me one thing. If I have to write it in the form of volume, I can write it as 22.4 liter. This is 3, so I'll multiply it by molar volume, that is 22 into, you can just write it directly as, why it is 84? This 14, I am so sorry guys, I'm little bit I did mistake here. N2 is actually 14 into 2, 28 grams. This reacts with 6 grams to give 14 plus 3, 4, 5, 6, 7, 17 into 2, right? So that will not be 84, that will be 34. Wait a minute, let me just correct it here. This will be 34, okay? 34 grams it is giving you. So this will be 34 grams of NH3. Okay, so I will not write it there. If you talk about volume, molar volume is 22.4. 3 into molar volume 22.4. This is 2 into molar volume 22.4. That becomes your volume. That this volume reacts with this volume to give this volume. Okay. Now, let's assume that you are talking about, ma'am, what about particles? In particles, you will see 1 molecule reacts with 3 molecule to give 2 molecule. This is also what you can say here. You can also write it as Avogadro's number of molecules react with 3 into Avogadro's number of molecules to give 2 into Avogadro's number of molecules of NH3. Right? Can we say that just by looking at this one reaction, I can tell you about so many things, right? And out of this, the most important is the mass and the volume. That is the most important thing here, right? Okay, that is the most important thing. What is the mass here, right? You have any chemical reaction. Okay, I'll give you one more chemical reaction. Let's say you have this chemical reaction. Now here you have to tell me all these things. Let's say you have H2 plus O2 give rise to H2O, right? This is the balanced equation, or right? So now you have to tell me what is this telling you? Firstly, it is telling me that 1 mole of H2 reacts with half mole of O2 to give 1 mole of H2. This is the first thing that it is telling you. Second thing is, it is telling you in a standard equation. Standard means in a balanced chemical equation, what happens? See, if you have an idea about stoichiometry, only then you can answer limiting reagent. Okay. So here 1 mole means nothing but 2 gram of H2 reacts with, this is 32 by 2, that is 16 gram of oxygen to give 18 gram of water, right? 2 gram reacts with 16 to give 18 gram of water. That is the standard equation. This is what it is telling you. It is also telling us that 22.4 liter of H2 reacts with 11.2 liter of O2 to gives 22.4 liter of H2O. Is that clear to everybody? Okay? By just this one reaction, by just this one equation, you can tell so many things here. You can tell so many things by just looking at this reaction. Okay? If that is not clear, you can let me know so that we can move further. We can start doing the questions. That was the concept of stoichiometry. Concept is simple, that these coefficients that you have here, these coefficients, they are telling you so many things regarding that chemical reaction. Now we will see how to apply that. Okay? Now we will understand with the help of questions how to apply that. Let's say you have a chemical reaction. It is said that 2 gram of sample contains SiO2. They are saying that SiO2 plus Fe2O3. It is in some sample. This is the sample. That is what? 2 grams. This is 2 gram of sample. On very strong heating, leave a residue. When you heat it very strongly, right? When you heat it very strongly, it leaves a residue weighing 1.96. Residue is 1.96. Residue we have, that is 1.96. Okay? We know that when Fe2, we also know that when you have Fe2O3, when it is heated, it will give you Fe2O4 plus O2. O2 is a gas. O2 is a gas, right? Now, after the reaction possible for loss of weight is this. That means how much weight we have lost. That is this reaction where this O2 you have lost, right? What is the percentage by mass of SiO2 in the original sample? That means you have to calculate the value of SiO2 here. This is the original sample where you have to calculate the SiO2. Now, these kind of questions is what they ask you in the exam, right? Now, bacha, understand one thing. If I am able to calculate, if I am able to understand that this is your Fe2O3, right? This is O2, right? Now, if I am able to calculate that how much Fe2O3 is there, then I can easily answer this. Okay? Tell me one thing. If I can tell that how much amount of Fe2O3 is there, then SiO2 will be 2 minus Fe2O3, isn't it? SiO2 will be 2 minus Fe2O3, isn't it? Right? Okay? SiO2 is 2 minus Fe. That means I have to calculate this thing. For that, what is given to you? For that, what is given to you? They have given you that residue is on very strong heating, the leave a residue weighing 1.96. That means the residue that, See, after weighing, this is the residue that you're left with. This is the gas. This will leave, right? This is the residue. That means this is given to be 1.96, right? Now, you have to calculate that how much amount will be there for Fe2O3, right? For that, what we will see, if I say that 1.96, I have to equate here with this thing, right? Okay. Now, what we will do, we will apply unitary method here, right? We will start applying unitary method here in this reaction. I'll tell you how to apply unitary method. See, this is the most important step here, right? You have this reaction here, right? Firstly, we need to balance this reaction, because I told you stoichiometry will be applied in the balanced chemical equation only. Otherwise, it is not applied, right? So this is the balanced chemical equation that you have. Now, in the balanced chemical equation, because the thing that we are provided with is gram, right? That this much gram you have, right? Now, what you have to see here is, see one thing, what you have to see here is that 480, that means this is 480, this is 480, this is 3 mole, okay? This is 2 mole, this is half mole, okay, right? Now, it's totally your choice what you want to equate it with. You can equate it with Fe2O3 directly. You can equate it with O2, which will be a simpler calculations. That's totally your choice, right? Now, see one thing here. If I say this is 1.96, this O2 is released here. If I subtract from here, total they have given you the sample is, original sample is 2 gram. Now, on strong heating, leave a residue weighing this. The reaction responsible for loss of weight is this, right? That means 2 minus 1.96 is nothing but 0.04. Now, if I balance this equation, on balancing in this equation, what I have is, this is half. If I balance this equation, this is 3, this is 2, right? And this is 6, this is 6. So this is 3, 3, 9, 9 oxygen, and here you have 4, 2, 8 oxygen plus 2 oxygen, 8, 9, 10, right? Okay. So what you have to, after balancing, what we got was 3 and 2, and this was half now? Yes. Okay, because here you are getting 9 oxygen and here you are getting 10 oxygen, right? So you can just multiply it by half to get the 9 oxygen on both sides. That is the balancing. Now, beta, see, I am going to apply stoichiometry here. For that, you have to see this thing very carefully. This was 1.96, that was the residue. That means after subtracting from 2, it will be 0.04. Now, we are going to say that if you see what is the, this is nothing but 3 multiplied by 56 multiplied by 2 plus 16 into 3. Okay? Solve this and answer you will get is 480. You can solve this, answer you will get is 480. So that means in 3 moles, you have 480 grams. This is 16 grams. Now I am going to compare these two things, right? So I am going to say, I need to find the Fe2O3. So we are going to say, in 16 gram of oxygen, you have 480 gram of Fe2O3, right? Now we are going to ask, then in 1 gram of oxygen, you are going to have 480 by 16 of Fe2O3, right? Then we want to see that if you have this much oxygen, because they are saying that, simple thing is, they are saying that in the reaction mixture, right? In the reaction mixture, you have SiO2 also, you have Fe2O3 also, right? Residue here can be Si also, Si2O3 or something can also be the residue, right? That means in the residue, you will have some component of silicon also here that is converted to this thing, right? So you are left with this oxygen, that is the remaining oxygen, right? Now this oxygen is reacted with how much amount of Fe2O3? This you have to see, right? You have SiO2, you have Fe2O3 in the beaker. You heat it very strongly, Fe2O3 reacts, it gives you Fe3O4 and O2. They are saying that the residue that you left with is 1.96, and in this 1.96 you have SiO2 and you have Fe3O4. Okay? Okay. But till here, if that is clear, this is, see, in the beaker, what you had is SiO2, you had Fe2O3, right? Now you strongly heated it. What happened here? I'm just going to draw this here because, you know, this is the important part. That in the beaker, what you had is you had SiO2 plus Fe2O3, right? When you heated it, this was converted into Fe3O4, right, plus O2, right? Now O2 will be gas, so it will be liberated out. O2 will be liberated out, it's a gas. The residue that is left is 1.96, right? In total, they said that you had 2.0, that is 2 gram, right? So in total, you had 2 grams. So minus 2, 1.96, O2 is nothing but that is 0.04. Now, that's why we are applying unitary method here, that if the oxygen is 0.04, then this is in 16 gram, this is the stoichiometry that we are applying. First, we will take the standard condition, that in the standard condition, 16 gram is going to give you 480 gram of Fe2O3. Then, in the question, we have 0.04 gram of oxygen. This is going to give you how much Fe2O3. So it will be 0.0 gram of oxygen is going to give you 480 by, this is 16 multiplied by 0.04 of Fe2O3. Right? Solve this beta. Till now, tell me if that is clear to all of you or not. Right? Till now, after solving this, you will get is 1.2 gram of Fe2O3. Right? 1.2 gram of Fe2O3. But now, once you have FeO3, what they are asking, what is the percentage of mass of SiO2 in the original sample? Now, we have calculated Fe2O3, right? In the original sample, right? If this was the amount of Fe2O3 that is being reacted, it's a very, very important question. If in the original sample, you had 1.2 gram of Fe2O3, so SiO2 will be 2 minus 1.2, that is 0.8 gram, right? And the percentage will be nothing but 0.8 divided by original multiplied by 100, that is 40%. Tell me if that is clear to all of you or not. Tell me if all of this is clear to you or not, right? Okay, students? Yes, everyone. If that is clear to all of you or not, let me know here. I think you are in shock or what? Hanji, that is clear now? What we did here, right? That is clear now. It was an important question, okay? Now let us see the next question here. That is 40 milliliter of gaseous mixture of CO, CH4 and Ne was exploded with 10 milliliter of oxygen, okay? So what you have is, you have CO, you have CH4, you have Ne. But I have not picked out very simple questions for you. We should do the questions that they ask in the exam, right? Okay, so this is where students hate this stoichiometry based questions, because they don't have as such formula. You have to understand the question, okay? 40 milliliter of gaseous mixture, this was exploded with 10 milliliter of oxygen. Okay? On cooling, the gases occupied this much, okay? After treatment with KOH, the volume reduced by 9 milliliter. Again, on treatment with alkaline, this volume further reduced percentage of CH4 in the original sample. Okay? Now, firstly, I'll take this as X. I'll take this as Y. I'll take this as Z. Okay? Now, they are saying that was exploded with oxygen. That means this is going to get exploded with oxygen. We need to have different reactions for that. So, CO can explode with oxygen to give CO2. and CH4 can explode with oxygen to give CO2 and H2, right? But tell me, will neon be exploded with this thing or not? Neon is not reactive metal. Neon is a noble gas, so nothing will happen to neon. Okay, firstly, that thing should be clear in your head, that what are the reactions that will take place, right? First reaction is this, and this. I'm going to write it here. CO, when it reacts with O2, or I'll just do this here, right? If you see this is CO. When it reacts with O2, it is going to give you CO2. This is half. Okay. Then the reaction is CH4. This reacts with O2 combustion. It is CO2 plus H2O. Then you have to, this will be 2, this will be 2, 4, so it will be 2. Okay, that will be the balanced equation. Now, Bacha, I told you that earlier I have taken it as X, this as Y, this as Z. So based on that, I need to find the oxygen that you have. Because they are telling me about the oxygen only. 10 milliliter of oxygen is there, 40 milliliter of gaseous sample. That means X plus Y plus Z is 40. Because the gaseous sample is 40. So we can say X plus Y plus Z is 40. Right? Now, next is, was exploded with 10 milliliter of oxygen, right? 10 milliliter of oxygen, that we will talk, but first you have to see this, right? That also we will talk, don't worry. This is X, so this is 1 by 2X, right? Okay, and how much amount is formed? The same amount that you have CO here, that means X amount will be formed here, right? This is again Y, this will be 2Y, and this is Y, and this will be 2Y, right? And now here you have to understand one thing, that originally what you have is X, and this is half X, this is Y, this is 2Y, right? Now, after the reaction, this is the combustion reaction, this is also kind of combustion reaction only. What is going to happen here? This is X, this is X by 2. Same amount of this will be formed here, because you have X only, then that amount will be formed, na? Because carbon is, let's say, 1. Then 1 carbon dioxide will be formed. Na? If you have 1 CH4, that means 1 CO2 will be formed, because 1 carbon will have 1 carbon only. Right? Okay. So based on this only, we can say that this will be X here, and this will be Y, and this will be 2Y. First, you tell me if that thing is clear to all of you or not. Right? Okay. This thing is clear to all of you or not. Right? Now, let's see the next thing. They are saying that on cooling, the gas occupies 36.5 milliliter. Now, bacha, 10 milliliter they are saying is the oxygen. 10 milliliter is the oxygen. Tell me one thing. I am saying this is Z. I am saying this is Z. Okay. 10 milliliter is the oxygen. So, oxygen will be this thing, added this thing. Right? This much oxygen is being exploded here. So, can I say that the amount of oxygen that you have consumed here is going to be, remaining volume will be, that is 10, that they are saying that it is exploded with 10 milliliter. And you have used X by 2, you have used 2Y. So that means this is the amount that you have used, X by 2 plus 2Y is what you have used. And 10 milliliter was total. So you will subtract here, that will be the remaining oxygen. Okay, that will be the remaining oxygen, right? So can I just write it here, that I'll write this way, oxygen used is X by 2 plus 2Y, right? Total oxygen that was exploded is 10, right? So can I say that oxygen left is 10 minus X by 2 minus 2Y. Okay, ji? Can I say that? Right? Okay. It remains as trace. Right? Can I say this, students? Now, next thing is what they are telling you. Wait a minute. This thing we have used, equation we have formed. This also equation we have formed. Not equation, but we have used it. On cooling, the gases occupies 36.5 milliliter. Now, bacha, tell me, what are the gases here? Can you tell me what are the gases here? What are the gases that are left behind? See, in a beaker, right, you have CO, you have CH4, and you have Ne, right? This after reaction with oxygen will give you CO2. This will give you CO2 plus H2O. H2 is not a gas, so we can eliminate this as well because we are calculating the gases. That means in the gases you have CO2, you have oxygen and neon, right? So can I say that? And here what they are saying that on cooling the gases occupied this. That means I have to calculate gases. Volume of, or you can say gases. Gases are, what are the gases? Gases is CO2, gas is neon, gas is what? What else? Gas is remaining O2. Okay, these are the gases here. Okay, ma'am, why you use one variable? Which variable? Chandu, you can write it down. You can tell me if there is some calculation or some mistake, right? One variable for one equation, two different molecules. I am not using different variables. No, I am using x here for one thing. X only I am using. I am not intentionally using this variable. It's not like I want to use this variable. This is, I am assuming this is x, this is y, this is z. This is the volume that I have assumed. Okay. Now they are saying that gases mixture contain total 40 milliliter. That means x plus y plus z is 40 milliliter. This they have given you in the question, right? Then they are saying that the gases are treated with oxygen. So after treatment with oxygen, only CO and HCH4 can get treated with oxygen. Okay. Now this after treatment will give you CO2. This after treatment combustion will give you CO2 and water, right? Now, next thing I am saying is this will give you CO2, this will give you CO2 and water. Next thing I am telling you is that here very carefully you have to see that this is if one, see if you have one carbon, only one carbon dioxide will be formed. So if you have X molecule of CO, X molecule of CO2 will be formed. If you have one Y molecule of CH4, Y molecule of CO2 will be formed, right? Okay. Now, second step they are saying is that was exploded with 10 milliliter of oxygen. That means the total oxygen is 10. Oxygen used is 1 by x by 2 and 2y. So I have added that oxygen used is this, total volume is this, oxygen left will be 10 minus this. Okay, till here it is clear. Can you please explain, ma'am? CH4 is 5 milliliter, how 6 will come? Wait a minute, let me see. I have not solved it yet. Okay, let me just see. Okay, till now, if till here it is clear to you that how oxygen left I am using. Why I am saying, ma'am, ma'am, in oxygen you put 32, but it is 96. Is it? Acha, by mistake, I think I would have put it. Okay, Chandru, by mistake, I think I would have put it. Okay. But tell me till here it is clear. Okay. Now, next is gases that you have. So gases we are saying is we have gas X, we have gas Y. But these are JEE Advanced level of questions, okay, that I am teaching you here. Because I don't want you to see easy question, ma'am. It's so easy, ma'am. I'll clear JEE, ma'am. Then when you see the exam, you're like, ma'am, you have not taught this, right? I don't want you to be in an illusion, right? You have to see the reality that these are the questions, if direct question from mole concept are asked. Okay, this will tell you which topic is strong, which topic is weak. Now, this was the total gases. Again, I am telling you, beta, in a beaker, you have 3 gases, X, Y, and Z. Total volume, they are saying 40 milliliter. They are saying it is exploded with 10 milliliter of oxygen. So here it is some oxygen, reaction will be this, balancing. This I have used stoichiometry here. 1 mole is giving you 1 mole, X mole will give you X mole. So X milliliter will give you X milliliter. Y mole is giving you Y mole, then 1 mole will give you 1 mole. So Y milliliter will give you Y milliliter. This is where I have used stoichiometry in this particular part. Okay. Now, then they are saying oxygen used is this much oxygen used, this much oxygen is used, right? Total oxygen is 10, so oxygen left will be 10 minus x by 2 minus 2y, right? Okay. Now, if you see gases, now the third part is what they are saying is gases occupied is this. Now you have to see what are the gases. This reaction has already happened. In the reaction, you have no CO, you have no CH4 now. You have CO2. So CO2 is from this side will be X, from this side it will be Y, right? And neon will be Z, neon is Z. And what is the remaining oxygen? That is 10 minus x by 2 minus 2y. This they are saying is equal to 36.5 milliliter. 36.5 milliliter. Okay. These are the three equations that you have here. Now after that, beta, simple. If till here you had chemistry, till here this is first equation and this is the next equation. This is also a very, very important equation, right? There is also one more thing that they are telling you, right? Because three variables needs three equations, okay? So you have this equation, right? You have this equation, second equation. Third equation will be after treatment with KOH, the volume reduced by 9 milliliter. Now they are saying after treatment with KOH, right? After this you treated it with KOH, right? Volume reduced by 9 milliliter. Now can you tell me KOH is used by which of the following? CO2 or H2O or neon? KOH is used by which of the following? That will tell you that which will be equals to 9. Okay. So bacha, KOH is reacted with this CO and CH4. This you should know that KOH reacts with CO and CH4. That's why the third equation will be X plus Y equals to 9. Okay. Because now in the mixture, you have CO2, you have Ne, you have remaining oxygen, you have, yes, you have water. All these things are there. Right? Okay. So this is the next equation that you have. You can just solve all these three equations. I told you that how we got these three equations. Solve this and you will get your answer. Okay, ji? Okay. Right, everybody? Tell me if any problem you have in this question. Right? Tell me any problem if you have in this question. Okay. So these are the three equations that you will form. How you will form, I have already explained you. If you have any problem in that, you can let me know in the chat box. Right? Okay, students. Ma'am, CH4 is 5 milliliter, ma'am. It is the final percentage will be 20. Okay. But a calculation, I will not do it now. Right? If your CH4 is coming out to be 5 milliliter or 6 milliliter, according to that, you can answer. If it is coming out to be 5, then it will be 5 by 40 multiplied by 100. If it is coming out to be 6, it will be this. Right? But all you have to calculate is the value of CH4 that we have assumed to be Y. You have to calculate the value of Y here. Right? You have three equations. You have to calculate the value of Y from there. Right? Okay. Okay, ji. That was the next question. After that, you have JEE Mains 2024-25 previous year question. See, on the same kind of question only this is. On combustion of this much of organic compound, right? Again, you have to understand this question. Every single question will be different in this, right? So on combustion of this much of organic compound, there is some organic compound. On this combustion, okay? So this is the compound. Its combustion, I am taking this organic compound as X. X plus O2 gives you containing C, H and O gave this much of H2O and this much of oxygen. So CO2 it gave you water, right? CO2 was how much? CO2 was water was 0.127 gram. This is 0.307 grams. Okay. The percentage of hydrogen and oxygen in the given compound. Okay. In the given organic compound respectively. total organic compound is given to you. You have to calculate that in this organic compound, how much amount of hydrogen you had, how much amount of oxygen you had. That will give you the percentage. Okay? See one thing, it is clear that amount of hydrogen, you can calculate it from here. Okay? See, here you will apply stoichiometry to understand that how much amount of hydrogen is there, how much of carbon is there, how much of oxygen is there, right? That's how you're going to solve this. That's how you're going to apply the stoichiometry here, right? Okay. Beta, in exam, they will not ask this. If they give you 2 options as correct, they will give you bonus marks, okay? Right? In exam, these things will not happen. Especially in JEE, this will not happen, right? Now, let us see what we are going to do here. First is, you have weight of carbon in CO2. Carbon in CO2. See, how to identify weight of carbon in CO2? See, carbon is 12 gram of carbon in 44 gram of CO2. 1 gram, it will be 44 by 12, right? And they are asking you how much amount of carbon in CO2, right? And what is the amount of CO2? CO2 is given to you, na? Amount of CO2 is given to you, isn't it? Achha, CO2 is given to you. Then we will do it a different way. We'll say that 44 gram of CO2 has 12 gram of carbon. 12 gram of carbon. Okay? 1 gram will have 12 by 44 of carbon. Now, 0.307 gram will have 12 by 44 multiplied by 0.307. And that's how you will get the weight of carbon, right? That the weight of carbon in this much amount of CO2 will be this much. Okay. Now, because in the organic compound, you have hydrogen also. Okay, you should calculate hydrogen also here. So weight of hydrogen in this much amount. How you can calculate this hydrogen? Simply by saying that 2 gram of hydrogen in 18 gram of water. 1 gram of hydrogen will be 18 by 2. And this was given to be how much? Water is given to be how much? Water is given to be 0.127. So 0.127 gram will have 18 by 2 multiplied by 0.127. That's how you have your answer as this much of hydrogen is there, this much of carbon is there, this much of hydrogen is there. Okay? Okay, ji? Okay. Now in this question, you have calculated the carbon, you have calculated the hydrogen. That you have already calculated. Right? Now, next thing what we will see is percentage hydrogen in the compound. Because see, one thing is clear for sure. The amount of hydrogen that you have here is the amount of hydrogen that you will have here. Tell me, hydrogen is coming only from organic compound. You are not adding hydrogen from outside. So the percentage of hydrogen, the gram of hydrogen here will also be here. Okay? That means if I am saying that if in this much amount of, what is the, wait a minute, what we have calculated here is, we have calculated it as 0.08, this is 0.08 coming out to be, this is coming out to be 0.0141. So this is 0.0141. So here the amount of hydrogen is this. In the organic compound, you have some amount of X, some amount of H, some amount of O. Let's say X, Y or Z. Okay? Now, if here you have this much amount of, in this particular gram of water, you have this much gram of hydrogen. That hydrogen is coming from the organic compound. That means in this organic compound, amount of hydrogen is 0.0141 gram of hydrogen in organic compound. Tell me if this thing is clear to everybody or not, right? So why this hydrogen that you have calculated here is same as this one, right? So percentage, we know that the total organic compound is this. Percentage of hydrogen you can easily calculate from here, right? So you can calculate percentage hydrogen in the compound is this hydrogen divided by total organic compound multiplied by 100. That will be the percentage of hydrogen, right? Okay. Now carbon is also coming from the same side. Okay. Carbon is also, if you see this carbon here, carbon is also coming only from this organic compound. So if you say this organic compound has how much carbon is nothing but 0.08 gram of carbon, inorganic compound, because carbon is also coming only from this organic compound. I am not calculating oxygen because oxygen is also coming from outside. That's why I'm not talking about oxygen, right? So I am only talking about hydrogen and carbon here. The amount of hydrogen that is there in this particular water is same, it is coming from this organic compound. The amount of carbon that is there in this carbon dioxide is coming out of this hydrocarbon, right? So this is your hydrogen, this is your carbon, right? That means percentage of hydrogen and carbon you can calculate easily. This is the percentage of hydrogen, right? Acha, they have done it in a different manner. You can also do it that first you calculate percentage of carbon, right? Let's say, you can also do it that way. I would advise you to do it that way, right? For that, just erase this, okay? Because that will be more easy for you to understand, right? Okay. So the percentage of percentage of carbon is going to be 0.0837 divided by 0.21 multiplied by 100. Okay? Calculate this, guys. What is the answer? Calculate this. What is the answer that you are getting here? 0.0837 divided by 0.21, right? Multiplied by 100. That is going out to be 39.85, right? So this is going to be the percentage of the carbon here, right? That obviously should be maximum, right? So now percentage of oxygen in organic compound is 100 minus, oops, why I did that? Oof, I have to write it again. Chalo, koi baat nahi. Okay. Percentage of carbon in OC is 0.0837 divided by 0.21 multiplied by 100. That is coming out to be nothing but it is coming out to be I think 39 point something, it was 0.0837 divided by 0.21, 39.85. Percentage of oxygen is going to be 100 minus 39.85 minus 6.719. Okay? So just calculate 100 minus 39.85 minus 6.719. It is coming out to be 53%. 53.43%. Approximate values also you can do here. ठीक है जी? Okay? Okay, everyone? Okay, Clara, I have specially made a video on that, right? Okay, on the books for JEE, so you can go and check that out. Okay, that is clear to everybody what we have done. This was entirely based on stoichiometry. You had this chemical reaction, right? Now we have no idea what is this organic compound. We have to calculate the percentage. They had given you hint about this much of carbon dioxide you have, this much of H2O you have. Now, this much of carbon dioxide means what you will have here is you can calculate the amount of carbon by applying stoichiometry. You can apply the amount of hydrogen in this particular gram by applying stoichiometry. So this carbon is only coming from organic compound. This hydrogen is coming from organic compound. That means in organic compound, you have this much hydrogen, this much carbon. Oxygen, you can't definitely say because oxygen is also coming out outside, right? Now we will calculate the percentage of hydrogen and carbon here. You can subtract it from 100, you will get percentage of oxygen also, right? Okay. Yes. Option B. Yes, you are definitely right. Option B is coming out to be the correct answer here. Right? Okay, Ji. Chal. Now, let us see the next. That is your, I think we'll start with the, okay, there is one more question. Already we have 50 minutes. Acha, tell me one thing. Do you want me to make a separate lecture of limiting reagent and empirical formula? Hanji? Because already today to it will take limiting reagent is also a lengthy topic only, right? So I would want to make a different lecture only on that, right? Can we do that? Will that work? Will that work? Or if you want to do it today only, I can do it today also, right? But I would want that, see, here we have solved good level of questions. In limiting reagent, I can also tell you that in 10 minutes, right? So the thing is that I want to solve like multiple questions on that because see, JEE Mains and Advanced, if you are targeting, you can't solve the simple questions. Simple questions on mole concept I taught you in the last lecture. Now today is the actual, you can see that these are the real questions. This is your JEE 2025 previous year question. These are the questions that they're asking you in the exam, right? So we can't just do simple question and we will say that I'll be able to crack JEE. That's not how it works, right? So just by doing the limiting reagent, it will not work, right? Okay? Okay, ji? Chal. Okay. Now, let us see. The next one is JEE Mains 2024 previous year question here. Combustion of glucose produces CO2 and water, right? Combustion of glucose, we are saying produces CO2 and water. So this is your glucose, C6H12O6, that produces CO2 and water, right? CO2, you have to balance this equation, that is a must. The amount of oxygen required to complete combustion of 900 grams. This is 900 grams of glucose is. It's not that of a difficult, it's actually a very, very simple question, okay? Right? You can easily do this. Acha, let's see what we are going to do here. Okay? Firstly, you need to balance this equation. If you balance this equation, how you're going to balance? First thing is balancing, right? So carbon is 6, so this also has to be 6. Hydrogen is 12, this also has to be 6. Okay? So carbon and hydrogen are balanced now, but oxygen is 6, 7, 8. Oxygen is here 6 to 12, 12, and this is nothing but this is 6. So that is 18. Okay? And here it is 6, 7, 8. So if you multiply this by, this is 6 plus 2. So if you get here 12, that is if you multiply this also by 6. 6 to 12, 12 plus 6, that is 18. I think now the equation is balanced, is it? Now the equation is balanced, right? Okay. Now once you balance the equation, they are saying that you have 900 gram of this, right? Glucose, you have 900 gram. Beta, you can do it in multiple ways. Combustion of glucose produces CO2 and water. Amount of oxygen in grams, this is what you have to calculate. How much oxygen is required for the complete combustion. Quite simple, right? So here, firstly, you need to see that this is the equation that I'll write it here. Already it is written, right? So here, what we will solve here is, this is 900 grams. This is 900 grams. I would also want to firstly calculate. See, you can do it in the mass also. You can compare it with masses also. You can do it in the form of moles also, your choice. But chalo, let's do it in the form of mass. So 900 gram of glucose requires how much amount? 32 into 6. 32 into 6, 6 to 12, 6, 18, 19, 192 gram of oxygen. Okay, 900 gram require this much. 1 gram of glucose. Hey, why I have written 190 gram here, not 900 gram. This should be 180 gram. Okay, we are talking about the molar masses. This much molar mass requires 192 gram of glucose. So 1 gram will require 192 divided by 180. Okay, that means, can I say that now to calculate for how much is given to you? 900 is given to you, right? So you can calculate that 900 gram will require 192 divided by 180 multiplied by 900 here. That is going to be the correct answer. 9 into 2. This is 10. This will be 5 here, right? So you can easily calculate the answer here. 192 multiplied by 5, right? What is the answer? 960. So D is coming out to be the correct answer here. That is 960 gram of oxygen is required for 900 gram of glucose. Okay. Yes, everybody. You can also firstly calculate the mole, then solve it in the form of mole, but directly also you can apply this with the help of stoichiometry, right? Okay. Okay, everyone. That is clear, right? So answer will be 900 grams. Now next is your limiting reagent. Now if you want me to do that, I can do that. If I see the students are interested, then I'll do that today only. But for that, I need to see that if you're interested or not. Can we do like this? Yes, you can do solve it with the help of moles also. I would not advise to do limiting reagent today. Reason is because limiting reagent is also a lengthy topic. Huh? You tell me. Do you want to do it today? Only one student is interested in today. You, so I know you can do 3-4 more hours of study. You can do, right? I see that students are very, very less here, right? So I would not want to waste the energy today. Rather, what I would love is that students should join in the next lecture so that I can start with the limiting reagent in the next class. Okay? Okay? ठीक है जी? Okay, right? हाँ जी. Okay, so that's it, students, for today, right? Already I have prepared the PPT of limiting reagent, but I feel that the energy in the chat box is quite less, but it's okay, right? Some days are like that. It's totally fine, right? I would want you guys to solve some questions of stoichiometry, because stoichiometry and limiting reagent are completely linked to each other, right? Then in the next class, we will learn about limiting reagent in detail. I'll show you different kind of questions here. We'll solve JEE Main, JEE Advanced questions, right, in the class, right? Okay. I know future IITian, I know you to will be there. I know some students like Rama, Raju, right? These students will be there, right? No matter I take class at 3 a.m. in the morning, right? I know that. But my energy also depends upon the students, right? If they like more crowd is there and they are more engaging, right? But don't worry, I'll teach that, right? Limiting reagent. And what I feel is stoichiometry has taken a lot of time. I thought it would take around maybe 20 minutes, right? But it had taken 1 hour. So that's why I would not suggest to do limiting reagent in the same lecture, right? Okay. Yes. So guys, that's it for today. And this is our Telegram channel. You can join our Telegram channel of Vedantu JEE English, right? And students, what is the homework? Let me just show you the homework here. Homework is also not there because homework I have taken. Homework is there for limiting reagent only. I have taken for limiting reagent only. So today you have no homework. So enjoy it. Right? Today you will have no homework. Right? Okay? Okay, ji? Yes. Yeah, teach shortly, Meena. What will happen? I'll start limiting reagent now, right? And I'll teach you questions in the next class. So the flow of the lecture will not be there. So maybe some students, they will join in only lecture of limiting reagent. So I'll have to again explain that to them. So that breaks the flow of the lecture, which I feel is not good, right? So that's why we'll start it in the next class. Okay, don't worry. I'll take extra classes on Sunday. Next Sunday, I'll take one extra class for you. Okay. Okay, I'll try to take, I'm not promising you, I'll try to take some extra class for you so that we can cover up the syllabus, but I want to teach you in detail. Okay, ji? Chal. Now, students, for all of you, beta, you can see in the comment section, in the description box here, right? There are courses that are running for you. First is JEE Pro course, right? Right now, off is going on in 2027 batch. 20,000 off is going on, where you have live interactive classes of offline like discipline. That means the teacher is also able to see you video call over video call, and I can also see you over video call. Your comments I can see, your that means anywhere in the class you can just speak and ask your doubts, right? You don't have to unmute or anything, right? You're already unmuted and your camera is already on throughout the lecture, right? So that helps us. And there is also protected, that will that means there is actually a mentor that will look for whether you are actually studying or not, right? So there will be proper parent teacher meeting, everything will be there, analysis will be there, hard copy books will be delivered to your house, 24/7 live video call solving will be there. Any time of the day you have any doubt, you can call video call, right? And in that app the teacher will pick up the call and you can ask your doubts in the app, right? Okay, so that is about your JEE Pro course. And for all the JEE 2027 aspirants, also 6 aspirants, also we have 1 year pro course that is right now 10,000 off. And if you are looking for a batch that is like friendly to the pocket, then we have this batch, that is Sigma batch, that is at 3,999, right? In this we are taking live classes. I'm also there in the batch, right? Shreyas sir is there, Namrata ma'am is there, right? We all are there in the batch. There are mock tests going on and live classes are being taken in the class. You have then test series are provided to you, QR cards, like these kind of cards are provided to you for your short notes revision. All these things are there in the batch, right? Okay, right, students? So that's it for today. Then I'll take your leave. Bye bye, take care, and see you all in the next class. Bye bye, take care.